Hello, ladies and gentlemen. Thanks for being here that early in the morning. I'm going to talk to you about application servers. My name is Antonio Goncalves. I'm a contractor in Paris. I created the Paris Java user group. I'm also running DevOps France on my spare time. And I'm here because I've been involved in the Java EE space for a long time. I joined BEA Systems. It was still called BEA Systems at the time. In '99, I worked with Weblogic 3, 4, 5, 6, left the company, did some Spring, came back to the Java EE world. So I've been, working on and off with Java EE, J2EE, for quite a long time. So I want to share a bit of my experience and tell you where we are now, a little bit where we come from, but also where we are now in terms of app servers. The idea of this talk is app servers have changed a lot. Most of them were there 15 years ago. JBoss was created in 2001. Weblogic is nearly 20 years old now. So they are pretty big beasts, but big not in terms of size, I'm going to show you, but in terms of the technology and engineering. And most of them knew how to evolve. And today we can do things that were not possible even 5 years ago. So I want to show you a little bit about that. How do we see app servers? Big block. One big block. App servers are slow, fat, big, not sexy, old, and boring. And people in the JavaScript world will tell you, and dead. I don't know if you've seen the new trend for 2017. It's called serverless. So we are, every year we have a buzzword, and it looks like the buzzword for 2017 will be serverless. Anyway, in the meantime, app servers are still here, and this is the way we see them. App servers are monolithic. Java EE, in the app server space of the full stack Java EE, we can find Weblogic, GlassFish, Websphere, JBoss, WildFly. But you might have followed the Java EE news, and since 2009, there's something that's called a web profile. So it's smaller. All these guys, Weblogic, GlassFish, Websphere, WildFly, JBoss, also implement the web profile. When you do the big blue box, you must also implement the smaller one. But there are some that only implement the web profile. And these guys are Apache Tomee, Caucho, Siwpass. Apache Tomee is the well-known of the web profiles. But you know that there's this little box, web containers, servlet containers. And in this space, we find Jetty, Tomcat, and Undertow. So Tomcat only does servlets, and Weblogic does it all. Java EE 7 is 34 specs, and Tomcat is only a few specifications. So app servers are not one monolith, 3 monoliths. No, it's not true, and you know it's not true. Because Java EE is, by design, bits and pieces. Even if we see that as a single block, when J2EE was created back in '98, it was already 6 specifications. Each specification has its life cycle, evolves differently from the others. So Java EE by design is a bunch of specifications. And we all know that Tomcat, Jetty, and Undertow at least implement these 4 specifications. Servlet, of course, and JSP, the expression language. The web profile, which was created with Java EE 6. In the web profile, you have CDI, JAX-RS, JPA, JTA. And when you take the big picture, Java EE as a whole, it's all that. So in the big blue part, you have EJBs and JMS. Batch. Batch arrived in Java EE 7. Security and concurrency. This is Java EE. Bits and pieces. And of course, it runs on a JVM. And there's people telling us that this JVM will be split in little bits and pieces with Java 9. And on top of all that, we have our business code. This is the little bit that that we develop. So this is our business code, and we let Maven do the rest. So Maven pulls the earth, and this is what we do, okay? So this is, when we work in the Java EE space, this is what we do. So app servers are not monolithic because by design, since day one, it's just a bunch of specifications. But app servers are slow, okay? We all know that. On my spare time, there's something I like to do. Usually in winter, when I'm bored at home, I download all the app servers on my Mac, not this one, the one at home, 16 gigs of RAM and so on and so forth. I download everything and I start them up. Here in green, you have the servlet containers, Tomcat, Jetty, Undertow. In the orange part, you have the web profile. So GlassFish, but web. Websphere, but the web version. And then the blue part is all the full Java EE stack. So what I do in winter is I'll download these app servers. I start them up. I stop, start, stop, start, stop. So they can warm up, create temporary files, and so on. And I look at the logs. How much time does an app server take to bootstrap? Empty. Okay, I haven't deployed anything. Well, if you look on the far right, Tomcat takes half a second to boot. But if you look in the orange part, Tomee takes a few extra milliseconds. And if you look on the very left side, something like WildFly 10 will take 2 seconds. So here you can see that on the far right, you have application servers that implement 4 specs, servlets, take 1 second, half a second. But on the other side, you have full Java EE servers that implement the full 34 specs of Java EE 7. And they bootstrap sometimes in less than 2 seconds. So, yeah, there's Weblogic in the middle. There's Weblogic in the middle, and maybe one day we will Websphere in the middle, because it took me 2 hours and a few tweets to understand that Websphere will not work on a Mac. It took me a couple of hours because I was lost in the IBM website, and I tweeted all my friends, and one guy said, "No, Websphere does not run on Mac." So I couldn't, I couldn't test Websphere. But in yellow, you have Websphere Liberty, the 8.5. It implements the web profile. And believe it or not, you go to the Websphere website, you download, you have a zip file, you unzip, you go start, and it starts. So IBM also did a lot of engineering work to get this happen. Another thing that I did, so that was a bit more tricky, because here I managed to find JBoss 3.2.8, JBoss 4.2.3, JBoss 5.1, 6.1, and 7. Because the first versions of JBoss didn't run on Mac, what I did is I create a Windows XP virtual machine. So the timing is a bit different because I'm running on Windows and on a VM. But it's not the time per se that is important. What's interesting is the yellow line. The yellow line is the number of specifications that make Java EE. Here, Java EE 7, 34 specs. Java EE 6, 5, 4, 3, 1.3. So J2EE 1.3 was 12 specifications. So as you can see, each version of Java EE increases in number of specifications. And look at the red line. The red line is I download JBoss, I go start, stop, and I look at the logs for the timing. And you can see that JBoss 3, which was implementing 12 specs, would boot in 5 seconds. And today, JBoss 7, that implements 34 specs, bootstraps in 4 seconds. And that is running on a Windows machine on a virtual box. So app servers are not slow. Things have changed, except for Weblogic. Oh, sorry, yeah, question?
Is there a penalty for that? Like, does it achieve those startup times by dynamic loading, for example, that makes it slow during runtime?
Yep. So the question is, how come these blue guys can be fast? Tomcat bootstraps in half a second and WildFly in 2 seconds, but it implements much more. Why? And why Weblogic is so slow? And the answer is some of them use tricks. GlassFish, when you bootstrap GlassFish, it doesn't do much. It's waiting for you to deploy something. So GlassFish only bootstraps the minimum. And when you deploy a WAR file, GlassFish will go, oh, it needs a CDI. I'm going to bootstrap CDI. Oh, it needs EJB. I'm going to bootstrap the EJB container. So GlassFish is a bit lazy. WildFly JBoss is much, much clever, and I'm going to show you an example, because it's actually going to bootstrap several things in parallel. And I'm going to show you an example. Okay, so app servers consume resources on your drive, in memory, really, really fat stuff. So again, I took all these app servers, and this time what I did is I bootstrapped them. I had a look at J console. I hit the GC, so the memory could go down, and I would play with the app server, a little bit. use the admin console, and so on. So because I was doing some GC and playing with it, you know, it gave me a minimum memory and a maximum memory used. And you know, again, look at Tomcat 9. The minimum memory that it uses is 20 megs of RAM, of heap, and the maximum would be 50 megs. But look at WildFly 9. WildFly 9, and again, when you launch the admin console, it's JSF console. So it has bootstrap the JSF container. WildFly 9 at its max takes 100 megs of RAM. JBoss 7 EAP is, you know, consuming a lot, but this is a beta, so that was beta 3, I think, that I've used. The EAP final just got released a couple of weeks ago. Because JBoss 7 EAP, it's supposed to be a fork from WildFly 10. And when you look at the consumption, it's a bit different. So it might get better on the JBoss EAP space. So app servers do not use a lot of memory. Okay, app servers use outdated packaging. And this is the interesting topic that you know, I want to dive a little bit more. This is what we do. You know, our little red code, you know, over there. We let Maven download a lot of stuff, and we execute that on a Java EE app server. How do we do that? Either we do it the Java EE way, we call it the skinny war. So, you know, the red box is my code and the dependencies that I've packaged in a WAR file and deployed on an app server, the skinny WAR. What we can also do is the fat WAR. So let's say the Spring way. You take everything and run it on Tomcat. So this is, you know, the two ways that we've been doing for 20 years, fat WAR or skinny WAR. So I'm going to show you a demo now, and I will play with that till the end. The demo I want to show is, I'm going to make it bigger. This fantastic website. So as you can see, I have books and CDs. I can do a search. There's, oops, you see, demo's not working. I can sign in as a user. I can look at a book. I can buy a book. So now I have a shopping cart. You know, I can see other books here and buy it. So now on my shopping cart I have 2 books. I can also log out, and I can log in as an admin. And when I log as an admin, I have the admin console here, and I can do CRUD operations on my CDs. So the database has 100 CDs, books. So this is a web app with EJBs, JSF, CDI, JPA, most of the Java EE specs. And if I go here, I can see that if I refresh this page, I have different top-rated books and top-rated CDs. That's because I'm calling external services. So here I have top CDs, and top CDs is just a service that gives me 5 CDs that are top-rated, and I have another service called Top Books, and that gives me 5 top-rated books. Everything is deployed under one WildFly. So I have the CD bookstore, the full web app, the top books, and the top CDs. So if I undeploy top CDs, No more CDs, okay? So if I refresh the page, I only have books. The service that gives me the 5 CDs is dead. And if I go to books, as you can imagine, it's not there anymore. And here on the front page, I do not have my top CDs and top books. We have 3 different apps with 3 different needs. They're all running on a full WildFly. We have the CD bookstore that uses most of the specifications. I do not use JMS, Batch, or JCA, but you can see that the CD bookstore uses JSF, EJBs, it has a REST interface. It uses Bootstrap and Prime Faces and jQuery to have all these sexy things. Then I have Top Books. Top Books also has a database, so I use JPA. I create my JSON with JSON-P, so I also use a fair bunch of specifications, but no EJBs or JSF. And then I have Top CDs. And Top CDs, I made it really, really small. It's just a servlet. I create the JSON by hand. So if I show you the code of my Top CD, sorry. If I show you, I'm not going to show you all the code, but just the Top CD because I'm going to play with that. It's just a servlet. Okay? It's a servlet, and I'm creating JSON with random numbers. So I have 1 class on Top CDs. In CD Bookstore, I have plenty. What a waste. What if we could package only the bits that we need in a jar file? Life would be easier. Because the CD bookstore, I could only take bits and pieces that I need. The top books, smaller. And the top CDs, even smaller. You know, top CDs, what I really want is the servlet specification, and that's it. And my 10 lines of code. We can do it. We can do it in the full Java EE space. There's WildFly Swarm that I'll be using. But there's also Payara Micro, Tomee, and KumuluzEE. These guys have been doing that for a few years now. Then you have a sort of Java EE, Spring Boot. Spring Boot uses some Java EE specs, Servlets, JPA. So Spring Boot also does that. And then you have others, you know, Dropwizard and Legume and so on. So in things that you see a lot with Spring Boot or Dropwizard, those things are possible in the Java EE space. Let's see it. I have my WildFly Swarm running here, so I'm killing it. Okay, I do not have WildFly running anymore. What am I going to do? Let's take the top CDs, 1 servlet. How am I going to take this servlet spec, my code, and put it in a jar and make it run? Well, I'm going to use the WildFly Swarm plugin. I'm not touching my code, so the code of my servlet is not impacted. I just have a WildFly Swarm plugin here. And it's this profile here. And I'm saying WildFly Swarm uses this notion of fraction. So I was saying bits and pieces. In WildFly Swarm, we call a fraction. So what is the need of the top CDs in terms of fraction, in terms of bits and pieces? Servlet, that's all I need. I need one fraction, servlet. So with WildFly Swarm, we use Undertow. So what I'm saying here is when you create the jar file, put this fraction inside the jar file with your business code. If I look at top books, and again, I don't change the code at all, this is a bit more tricky. Top books uses CDI and JPA and JAXRS and JSON-P. So what I'm saying is I'm telling WildFly Swarm, use the Undertow fraction, servlet, JAXRS and CDI, and with JAXRS is going to also pull dependency based on JSON, so I'll have JSON-P, and JPA because I have a database. And as you can guess, the CD bookstore, the one that has everything, I have more fractions. I have the EJB fraction, the JSF fraction. So here I'm doing a Maven profile called Swarm. So now I go back to my application. So I have the CD bookstore, top books, and top CD. And I do Maven clean install. And I use the Swarm profile. So what WildFly Swarm will do, it is going to package all my code in a WAR file. So I will still have the top CD in a WAR file. He's going to take this WAR file and put it in a jar with the needed fractions. So then we will have a look at the content of the jar file. And the jar file is basically your WAR plus the fractions. So it's a WAR inside a jar. And we've been doing the other way around for 20 years. Okay, so is this working? Hopefully. So I'm going to CD bookstore, big one. No. I'm going to go to top CDs, small one. I'll start with this one. As you can see, I have a WAR file, and look, I have top CDs dash swarm. And the jar file is 37 megs. So I just do java dash jar, and I'm going to execute this jar file. Logs, WildFly Swarm, WildFly logs. So these are just logs of Undertow. If I go back to my top CDs, I need to change ports. So now I'm going to have 3 applications running in 3 different ports. So top CD is working now. I'll go to top books and do the same. So the top books uses more fractions, JPA, JAXRS, and CDI. So the jar file is 100 megabytes. Java jar. WildFly Swarm. You can see there's a data source. So I have a database. And I'm going to go to top books. Again, change ports. Good. And the big one. The big one, the one with EJB. Target. So here the CD bookstore dash swarm is 123 megs, because everything is packed in. It's going to take slightly longer to boot. There was a JNDI name because there's EJBs. H2, so I'm using Mojara, so I'm using JSF. And now it should work. Aren't you impressed? Wouldn't you clap? And what about multiple apps? Yeah. You know, this is a microservice. You know, I was talking about buzzwords. This is a microservice. Top city is quite small. So I want to have plenty. And imagine when I have Java 9 modules, because I just need a couple of JVM modules. Easy, let's do that. You know, they listen in different ports, so I can do that really easily. But I just want to show you what we can do in terms of packaging. So now I've put a war inside a jar, but I can go, you know, I can go even further. What would you do? When you look at that, don't you see that there's a copy-paste? Let's take the servlet fraction out and leave it in the Maven repo, and then point to it. Demo. Top city, I'm going to focus now on top city because it's smaller. And top city, here I have my Swarm profile that tells me I just need the Undertow fraction, and I'm listening to port, you know, on port 8081. And now I have this profile here, the Swarm M2 repo, which is exactly the same. I need the Undertow fraction. The only thing here is I'm saying do not bundle the dependencies. That's the only difference between the two profiles. So if I go back to top cd here and killing it, I build it with M2 repo profile. Remember that that was 37 megs, 30-something megs. Well, now top cd swarm is only 8 megabytes. And if I execute it, look at here. Dependencies, dependencies not bundle will resolve from local M2 repo. And, you know, it's working. I'm not sure I'll use this kind of packaging because the idea is you bundle everything into a jar file and you put that in any server with a JVM and you know, and it works. Here, in this kind of architecture, you need to have the fractions on the M2 repo. But it's just to tell you where we reach, well, the sentence is not right, but we've reached this point now where, you know, we went from bundle everything into a jar, but we can even go further. You know, where the jar files are pointing to dependencies. Let me give you some metrics. The green bar, I go on the web, I download WildFly 10, zipped, it's 140 megs. If the CD bookstore, if I deploy it just in a WAR file, so the little blue bar, the skinny WAR, it's only 5 megabytes because I have my code and dependencies, that's all. But look at the yellow bit. It's my code plus all the needed fractions. So the CD bookstore is nearly as big as WildFly because it contains most of the fractions. But on the other side, the top CD, it's only 37 megs. So I took bits of WildFlies, the fractions that I needed, and packaged them into a jar. Startup time. So I'm going to answer the question that was asked. Startup time. Green bar, WildFly empty. Okay, so the green bar is I take WildFly 10, start, stop, start, stop. It takes roughly 2 seconds to bootstrap. An empty WildFly. Top CD is at the top, the yellow bar. It's only a servlet with the Undertow fraction. this bootstraps in 1 second. Top books in a jar file, so that's the yellow, it bootstraps in 3.5 seconds. And CD bookstore in a jar file in less than 6 seconds. Then I'm going to show you something a bit weird. Look at this bar here. CD bookstore. That's the skinny WAR, so the code of my CD bookstore packaged in a WAR file and deployed in an empty WildFly. So if I take the CD bookstore, put it in a WildFly, and bootstrap the WildFly, it takes 8 seconds. 8 seconds to bootstrap the server plus the app. But what I've showed you before, the first demo, was the 3 applications packaged in a WAR file, deployed in WildFly. It takes 6 seconds. So WildFly bootstraps faster 3 apps than 1 app. I didn't get that. You know, I tested 10 times saying something is wrong. Then I called a few friends at Red Hat JBoss, and they told me, yes, that's because WildFly bootstraps things in parallel. So when you deploy the top CD, it bootstraps fast, but at the same time, it warms up the web container. Then the top books arrives, the web container is already warmed up. It warms up JPA, and the CD bookstore arrives, and everything is warmed up, you know, already. So that's how clever app servers have become. Deploying 3 apps is much faster than deploying 1 app. Funny. Okay, how do I manage it now? So you go to your production team, you give them a jar file, and you go, easy, java-jar. And the guy is going to say yes. And what is the name of the data source? Where is the GMS factory name? Where is the password? How do you manage that? Well, there's 2 ways. One way is you put a bit of code inside your jar. So here I have a main file, and WildFly Swarm comes with this API saying, I'm going to create a new container that I'm going to start and deploy, ultimately. And in this container, I'm going to create a data source, which this name and this driver, and this connection and this password. So one way of configuring your application, if you need to point at this data source, it's like that. But the other way is WildFly Swarm comes from WildFly. They already have a configuration API, a configuration CLI command. Why not use it? Let's do that. So here, I'm going back to my top CDs because it's the smallest one. And look at that. I have a different profile saying my servlet, package it with the Undertow fraction, and the management fraction. Oh, let's do that. So here, I'm using the management profile. So now 2 fractions will get bundled inside my jar file. Java-jar. So top CD, there was a log saying management enabled. So, you know, it's still working. So top CD is still working. And now you can tell your ops, well, it's just, you know, what's inside is a JBoss. So you should be able to use your standard JBoss CLI. So I connect to my running JBoss, and I can go, what's deployment, or what's the name of the command again? The JBoss CLI is a bit of a, oh yeah, deployment info, yeah. And it's saying, well, there's a war deployed. And it's quite funny because the command is deployment info. And we've been for 20 years, our mind was a deployment is you take a war and you deploy it into a running app server. And now it's just a jar file running. And I told you the structure of the jar file, there's the war inside. So when you do deployment info, it tells you, well, in this instance of WildFly, there is this jar deployed. And now I have all the goodies of the JBoss CLI command. So you can tell your operational team, just manage it the way you used to. Okay, so if you want to create a data source and configure it, you can still do that. Yeah, question? Yeah, the question is, if I create a data source and then shut it down and restarted, it has vanished because everything is in the jar file. And the configuration of WildFly is in an XML file. But what you can do is when you customize, so here, you can have a bit of code saying the configuration of this instance is on / blah blah / blah blah. And what about Docker? You know, to get accepted at this conference, I had to put as many buzzwords as I could in my abstract, so I could fill up the room at 9 a.m. So what about Docker? Simple. What do I need? Java. I need to expose a port. And then I just go java-jar, and I give it the name of the jar file. This is my Docker file. You know, I don't have to go through thousands of lines to configure my stuff. Demo. I'm going to shut down my top CD, so it's not working. Don't be jealous, but I have the beta Docker application. No update on stage, thank you. Remind me later. So I'm lucky to have the, you know, if you want the Docker for Mac or Docker for Windows, you need to register online and wait to receive an invitation. Or you know a few friends at Docker and they, you know, and give it. So I have Docker for Mac, which is quite a nice beast. Top CD, Docker file, okay, I just have that. So I go Docker compose. It's going to take my Docker file and execute it. Simple. I just need Java, I expose a port, and I execute a jar file. I think you can clap now. But not too much, no. Not too much, because I'll finish with the Raspberry Pi. We all run our production on clusters of Raspberry Pis, don't we? So again, you know, my last buzzword was Raspberry Pi. And I'm going to press the button. Technician, ready? Ready? Ready. People, ready? Ready. Okay, do it again. Ladies and gentlemen, EJBs running on a Raspberry Pi. And now you can clap and stand up. So this is for real. So you have the 3 services, at the back, top CD, top book, and the web application. I had to fill up the box, everybody says that the Raspberry Pi is small, but I had to put the Raspberry Pi, the plugs, the cables, the keyboard, the screen. But because we all run Raspberry Pi in production, I had to do it. Okay. So what I also wanted to show you on this top CD is the structure of the jar file. So the top CD swarm, which is 37 megabytes, I'm going to unzip it in a directory called structure. Okay, I go to structure. And look in structure. Inside there's this directory called M2 repo. So if I do a tree on all this, it's a bit long. There's a lot of files and directories, but if I go up quickly, so you have a bunch of WildFly Swarm properties to bootstrap the application and so on. So again, you can put this configuration outside the jar file and point to it. Oops, not a lot of time. What's funny is, as I said, you have the WAR file inside the jar, which is interesting. And then we have our good old M2 repo. So what WildFly Swarm does, it relies on Maven and dependency management to basically take all the needed jar files of each fraction. So here you have your big, I was, you see, I don't even know, I was talking to the guys at WildFly Swarm, but this is the top CDs, and top CD just needs an Undertow fraction. And unfortunately, I don't know why, but it's pulling me a CDI and inject. And basically what I need is just servlet. So there's still, WildFly Swarm is in beta. So I think there's still a bit of work to make it even smaller because, there are stuff here, the concurrency, I don't need it. So I hopefully, I hope that this guy will shrink it a little bit more. You can also exclude stuff. You can tell the WildFly plugin explicitly, do not push a CDI. But, hopefully they will do it better in the future. So now it's 37 megs, but it might even shrink a bit. And then, so here I have all my dependencies. And then I have, because it's based on JBoss modules, all the configurations of the modules, and a few classes to bootstrap. So this is the structure of the jar file. Some final words quickly. So WildFly Swarm, what I like, it's based on good old JBoss. So even your ops guys know it. They use JBoss the old way, and it's easy to use it the new way. And I've just shown you the Java EE fractions. But WildFly Swarm comes with a bunch of other fractions. Spring, but also all the Netflix stuff. And tomorrow there's a lab about it, and it's quite interesting because when you have all these microservices, how do you know where they are, in which pod they listen to? And WildFly Swarm just went, I use Netflix. They know how to do it. So they also created fractions for all the Netflix stuff, and Logstash and Swagger, so and plenty other, and the ecosystem is growing. So final word for app servers. App servers have changed. They are not monolithic, I've showed you. They are not slow. They are not huge beasts like they used to be. We've packaged either jars, WARs, ears, but now we have this new way of packaging, so we can put our WAR files inside jars, and the dependencies, we can even leave them in the Maven repo. What I like with that is I can reuse my expertise. You know, I know JPA and JAX-RS. Well, I just create a microservice the Java EE way. So yeah, Lukmar, you know, this was a microservice. Yes, another buzzword. But you can, you can also create a centralized app with this technique. And it's fine, you know. Not everybody has to run microservices in production in a Raspberry Pi. So if you want to know more, I have this fantastic book, you know. My mom is really proud about it. I also do Java EE courses on plural sites. And I'll be sitting at a table at 1:15 at Meet the Speaker, first floor. So if you want to come and have a chat. No time for questions, sorry. Thanks.